this video, we're going to introduce you to a very important device used in process control today, the transmitter. Alright, let's go. First of all, let's talk about the term transmitter, because it has more than one definition. In the telecommunications world, a transmitter is a device that produces radio waves radiating from an antenna. In the world of process control, a transmitter is a device that converts the signal produced by a sensor into a standard instrumentation signal representing a process variable being measured and controlled. In the early days of process control, the standard instrumentation signal was pneumatic, while today it is more likely to be an electrical signal. The standard pneumatic signal is 3 to 15 psi. The standard electrical signals are 1 to 5 volts or 4 to 20 milliamps. And just to add a bit more confusion to the term transmitter, some people in the industrial instrumentation field will tell you that a transducer and a transmitter are the same thing, and therefore the terms are interchangeable. As mentioned earlier, the electrical transmitter output signal is usually a range of voltage, 1 to 5 volts, or current, 4 to 20 milliamps. In process control, it is understood and goes without saying that the transmitter output range represents the 0 to 100% of the sensed physical variable. For example, the transmitter would produce an output current range of 4 to 20 milliamps for a measured temperature range of 0 to 150 degrees Fahrenheit, 0 to 100%. We've talked a lot about the transmitter and the sensor. Let's have a look at where the transmitter fits into a process control loop. As already stated, the transmitter converts the signal from the sensor to the process variable, or PV signal, which represents the physical measured variable. The controller is the device that looks at the difference between the process variable, or PV, and the set point, or SP. The controller then determines what action to take place and generates an output signal that is a function of the result of this comparison. Controllers are either a DCS or a PLC in process control today. The final actuator is the device, such as a valve, that exerts a direct influence on the process as directed by the controller. The four major process variables measured and represented by a transmitter are pressure, level, temperature, and flow. Transmitters are also used in industry to measure other variables such as position and speed, and chemical properties such as pH and conductivity. A transmitter requires a power supply to operate, as discussed in our video, what are 2-wire and 4-wire transmitter output loops. Let's review quickly. A 4-wire transmitter has 2 wires connected to a power supply, and 2 signal wires connected to the PLC. The power supply can be AC or DC, depending on the vendor and model. A 2-wire transmitter has only 2 wires. These 2 wires provide power for the transmitter and are also the signal lines. New technologies have spawned the development of smart transmitters. Smart transmitters not only produce the 4 to 20 milliamps process variable signal, but also transmit and receive digital information such as instrument tag names, calibration data, and sensor diagnostics. Protocols such as HART are commonly used on smart transmitters. Okay, let's review. In the telecommunications world, a transmitter is a device that produces radio waves radiating from an antenna. A transmitter in process control is a device that converts the signal produced by a sensor into a standard instrumentation signal representing a process variable being measured and controlled. The transmitter standard pneumatic signal is 3 to 15 psi. In instrumentation, the terms transducer and transmitter are quite often used to name the same device. The 4 major variables measured and represented by a transmitter are pressure, level, temperature, and flow. Instrumentation transmitters can be connected in a 4-wire or 2-wire configuration.